Welcome to Lesson 4, where we will evaluate studies using the PICOS framework, and we'll also use this framework to make sense of conflicting study results. So, there is a common problem that all of us have faced, and a problem that really frustrates the lay public and even many professionals, and that is conflicting research study results. So, a lot of times you'll hear people say scientific research is meaningless because for every study that says one thing, you can find another study that says the total opposite. So forget science, it's just a big bleep show. Well, if we resort to just wholesale dismissal of science, then what we're left with is just speculation and intuition and hearsay and much more treacherous means of gaining knowledge of reality. So, the way that we can get around that and be able to evaluate studies and make sense of different study results is through what's called the PICOS framework. And this is an acronym that I will go over. So, P stands for population. Population refers to who is being studied. So, what are the characteristics of the population or the group of people being studied? Are they humans? Are they animals? Hopefully, they're humans. In the field of nutrition and exercise, we are actually beyond looking at animal models. An argument can be made to use animal models for medical research, for pharmaceutical research, for various other lines of research. But when it comes to nutrition for goals that we pursue and help people achieve, we can pretty safely stick to human research. So P stands for population. Who are we studying? Now, if in fact they're humans, are they in a state of health? Are they in some sort of stage of disease? Are they lean? Do they have excess body weight or body fat? Are they athletic subjects? Are they trained subjects? Are they sedentary subjects? Who are we looking at here? So that's the P in PICOS, the population. And many times, studies with conflicting results will boil down to the very first letter in the acronym, P for population. I stands for intervention. So, in other words, what is the experimental agent that we're looking at? Or if it's observational literature, what is the exposure that we're looking at? So, an intervention, for example, and I'll just use the same one for convenience, we can just use creatine. So, what is creatine being compared to? Okay, so if we didn't use creatine for the intervention aspect here of this acronym, we can jump over to the exercise world. We can use high reps, low loads, and high reps. That can be an intervention. And basically, the intervention is what agent or protocol are we putting to the test? That's what the intervention is. What's the comparator? Are we comparing creatine to some sort of inert placebo control like a sugar pill? Or are we comparing a low protein intake, like at the RDA level, to double the RDA? Okay, so what is the intervention and what is the comparator? In some cases, it could be an experimental agent and a placebo control, or in other instances, it can be something like a high carbohydrate versus a low carbohydrate diet, high reps versus low reps, time restricted eating or conventional round the clock eating. The comparator is what are we comparing the experimental treatment with? That's what the C stands for, the comparator. O stands for outcome. Outcome refers to what effect are we anticipating? What effect or what adaptation or what consequence are we anticipating as a result of putting this experimental agent into play? So, with the creatine example, I gave the example of anticipating changes in muscle size and strength. Those would be outcomes. And another outcome would be changes in body composition. So, outcome refers to what result, consequence, or effect. What outcome are we anticipating? Or what outcome is being tested for? Okay, so S is the final letter in the acronym that stands for study type. So what is the nature of the research we're looking at here? So is it if we look, the PICOS model, it works really well when you're looking at experimental or interventional research, okay? Is it a short-term response study, or is it a longitudinal study where we're looking at effects over a period of weeks or months? That matters quite a bit because usually with short-term response studies, you can really tightly control them, but they don't necessarily predict what happens on a chronic basis in the long term. And so we need the short-term studies maybe as a jump-off point, a starting point to generate hypotheses and proceed with the longitudinal studies that look at effects over weeks and months to see if this effect that may have happened in the short term is persistent over the long term and what it results in at the end of a longer study. So with study type, duration is important. Another aspect you can look at with study type was it experimental research or was it observational research? So what was this research capable of demonstrating causation, or was it one of the very many epidemiological studies that are more than anything hypothesis generating rather than confirmative of some sort of definitive answer? So yeah, study type. And if you'll recall back to my long lesson on the different research types, randomized controlled trials versus observational studies. So experimental research versus observational research. The strength of observational research is that you can look at large populations for long periods of time and you can examine endpoints that are pretty much unfeasible to examine in randomized controlled trials. So you can examine endpoints such as disease and death, whereas it's unfeasible to do that in randomized controlled trials because it's a logistical challenge and it's a financial challenge and sometimes it's an ethical challenge. So study type matters. So that is the PICOS acronym for making sense of differences in results across different studies. You just run them through the battery of PICOS, and the differences in the methodology will jump out at you. And I'll reiterate that a lot of times it's just differences in the population that make all the differences in the results. And sometimes with the intervention, it's just differences in the dose of the experimental treatment of the agent. Differences in the dose can make all the difference in the results. So that is PICOS. And just some overarching questions to ask when you're looking at a study and evaluating it. Ask yourself, how relevant is this study to my personal interests? So if somebody's waving a study around in your face, does the study address the topic that we're arguing about? does this study actually apply to my characteristics? Does it apply to resistance trained, physically active subjects, for example? And the other question that you should ask is, how do these findings stack up against the current backdrop of the human research evidence? Are they in line with it, or are they somehow anomalously out of step with it. And what's different or what's better about this study potentially that could maybe buck the trend of what's been seen in the majority of the evidence? So those are some questions to ask. And just an example of the study evaluation in action, the PICOS thing. So this particular study or this particular headline made the claim that eating too much protein is bad for your arteries. And I can tell you that this was based on rodent data that has a ton of limitations and caveats. But when it shows up on a headline of a major media outlet, then of course it causes hysteria amongst the general public. And yeah, there's a rat to represent what the study was done on. Human research matters. We can say, okay, what's the population that was studied? Rodents. So when we look at human research on high versus low protein diets on both clinical outcomes as well as body compositional outcomes, we always see favorable results with the higher protein condition. And so that is just a brief example of just using one aspect of the PICOS acronym to evaluate research. P, population, who was studied, what's the intervention, what's the comparator, what's the outcome, and what is the study type. And with that, we have concluded lesson 4. Stay tuned for lesson 5, where we will use a scientific search strategy to gather information and evaluate a claim.